Hello, everybody. Good morning, good afternoon, good evening, as may be the case where you live. Thanks for joining us for our last of 2020. Oh, that has a nice ring to it just in general. 2020 coming to an end, but the last 2020 PL SQL Office Hours session, and I'm very pleased to have a special guest with me to do that. So my name is Stephen Feuerstein, developer advocate for Oracle Corporation with a focus, some might say obsession, on PL SQL. What are we going to talk about today? Let's take a look. So the session for today is called PL SQL, The Good Parts, and it'll be featuring Morten Braten. So for those of you who haven't been around as long as I have, Morten might be a new name for you, I suppose. He's been working around Oracle database and Oracle technology for some 20 years. Actually, 20 years as a consultant and software developer. Morten, when did you start with Oracle database?
Actually, it was in around 1997.
Oh, okay, so 97. Yeah. So I've only got 10 years on you. So what? So Morten has really been focused on Oracle database and Apex for a number of years, and he's been very creative in his use of the technology. I'm sure he'll share some of that experience with you, but also he's known for having published several years ago a paper called, or a presentation called PL SQL, The Good Parts, which has been quite popular. And I thought it might be nice to bring him on board for our PL SQL Office Hours session and have you do kind of a reprisal and perhaps a bit of an update on PL SQL, The Good Parts. So with that, I'm going to turn it over to Morten and let him take it away. Morten, it's all yours.
Okay, thank you, Stephen. Thank you, Stephen, for having me on the PL SQL Office Hours to present about PL SQL's so-called good parts. And as you said, this was a presentation that I published online a couple of years ago, and it was inspired by Douglas Crockford, who did a talk about the so-called good parts of JavaScript. And Douglas, he later wrote a book about it, which turned out to be a rather short book. But fortunately, this is not a talk about JavaScript, so let's just move on.
Looks just like my PL SQL book, except like 1/10 the size.
Yeah. So first, a couple of words about myself. Stephen already did some introduction, but as he said, I'm a software developer and a consultant, and a freelancer and a small business owner, and I've worked with the Oracle database and PL SQL since around 1997. And I have a blog, I have a GitHub repo where you can find my open source projects, and I have a Twitter account where I tweet and retweet stuff related to PL SQL and Apex as well. So note that this presentation is not an introduction to PL SQL, and it's not a complete overview of PL SQL, but it's just me talking about the things that I like, my personal favorite features of PL SQL, and the kind of things that I think makes it unique and pleasant when you're working with data-centric business application in a relational database, which most of my work has been. So there are lots of programming languages out there, and many of them are quite complex and ever-changing and always adding new features. PL SQL, on the other hand, is quite a simple language, which I see as a good thing, and indeed that's the first good part of PL SQL, that it's so simple. So it's quick to learn, it's easy to read, it's easy to understand, and it evolves really slowly. Some would maybe say too slowly. But you don't spend a lot of time just keeping up with new features, and you can be productive and focus on solving your business problems instead of keeping up with the language. So PL SQL, as you probably know, is short for procedural language, structured query language. And it basically means we can put some if statements around SQL queries. And SQL in itself is awesome, and with a well-integrated procedural control around it, this combination makes it a true awesome sauce combination. So if you say to someone that you work with PL SQL, they probably give you a strange look, like you're some kind of old dinosaur working with ugly code that they wouldn't touch with a 10-foot pole. And it's true. I've seen a lot of ugly PL SQL code that is all uppercase with like this and with weird indentation and no proper structure, no comments, etc., etc. But it doesn't have to be like that. With the right approach and the right tools, PL SQL code can look good and it can be a joy to work with. So I'll talk a bit more about the tools later in the presentation. Code that runs inside the database is often called a stored procedure. And the term stored procedure has kind of a bad reputation among more mainstream developers like the Java and C# people. And I think personally that much of that bad reputation is to blame on the kind of stored procedures you can write in non-Oracle databases that for a long time lacked basic features such as exception handling. So if you're used to MySQL and the stored procedures you can write there, it's not really that pleasant to work with. But it's kind of remarkable that PL SQL had all these features from the very start, some 30 years ago, including functions, exceptions, and perhaps most importantly, the concept of packages, which we'll talk about more shortly. So let's look at the good parts of the PL SQL language itself. As mentioned, the concept of a package where you can split the specification or interface from its implementation or body, it's a very powerful concept. Because it means as long as you design good specifications, then you are free to change and improve the implementation, the inside of the package as much as you want, without it affecting other parts of your application. So by splitting your applications up into multiple packages with clearly defined responsibilities, you get a system that's easier to maintain and you can reuse code. And in fact, I would go so far as to say that you should never ever create a standalone procedure or function. It's always a good idea to place procedures or functions inside a package, even if you only have one procedure. There is always going to be more. And it's better to have too many packages than too few. For example, you could have a package that handles customer information, and then you could have a separate package that handles import and export of customer information. So you split it up into multiple areas, even within the same entity. Now, in packages, you can declare constants, and they are great because you can define the special values of your application once and then reference it from other code. And there's only one place to change the value if you have to change it. And you never risk mistyping the actual value because the compiler will check that you have used valid constant name. So if you try to use a constant that doesn't exist, the compiler will tell you. So we can look at some examples. I have some code here. I have a package and these constants, they are defined nice and readable names, and I can then use these in my code. So if I look at another package, I see that I can easily then reference these constants, and the compiler will tell me if I mistype them, and I also get like code completion for these values when I use a tool that supports that. Now, it's too bad that these constants can't be used in pure SQL, that is outside of PL SQL, but we'll get back to that later towards the end of the presentation. So overloading, that's another good thing that allows you to use the same name for many functions or procedures, as long as the parameter names or data types are different. So you can use this to make flexible APIs where the caller doesn't have to remember all the different name variations. And I have a small example here with a package that has two functions to create a new invoice, and they have the same name. They're both called new invoice, but they take different sets of parameters. So one takes separate values and the other takes the whole row of the invoice. And which one you use, it depends on the parameters you supply. Default parameter values, they are one of my favorites because you can put in the defaults that make sense in the most typical use cases, so that most calls will be short, but the extra parameters are still there if you need to specify something other than the defaults. So it makes for shorter and more readable code. And you can define these in two different ways. either using the default keyword or the colon equals assignment.
Which do you tend to use?
Well, I like the default syntax because it's more declarative, but out of old habit, I tend to use the colon equals just because it's faster to type, I guess. So, but I like when it says default, it's obvious what it is. So, yeah. Okay, and then we have named parameters, and that's also a favorite of mine because it makes function and procedure calls so much more readable. And just imagine, especially if you have Boolean parameters, you don't use named parameters. When you read the code, you just see a bunch of true, true, false, true parameters, and you have no idea what it means. So if you specify the names of the parameters, it becomes very, very readable. So for example, I have a package here, and it has a procedure to purge some customer data, and it has two parameters, and one of them is a Boolean that says if you should also delete the corresponding audit trail. And then imagine if I try to call this, and I say, for example, something like this, true, and then when you read the code, you have no idea what that true really means. But if you include the parameter name, then it's obvious. Everybody that sees that immediately know what it does. Then we have user-defined record types, and they can be used to pass around multiple values that are not directly mapped to a table row. So it might contain composite or calculated values, so like maybe data from two different tables. And this makes for flexible code because you can add more fields to the record later, but the signature of the functions where you've used it could be return values or the parameters itself. They don't change. So it's a good way to future-proof your code or be able to expand it later. So for example, in package here, I have a package that is an interface to PayPal, the PayPal API, and I've used record types here to, for example, create like an access token that contains these fields, and a payment record that contains certain fields, and then the actual procedures there or functions, they actually take in then the access token and then and return the payment information. So if something gets added to the payment structure later, I can just add it to the record, but I don't have to change any code. Small thing, the in operator, it's I've often missed this in other programming languages because without it you have to type if value equals this or value equals that or value equals blah blah then. But with the in operator, you can just list all the values, so it's more easy to read and easy to write. The case statement that exists in most languages, and it's very readable, and use it instead of a bunch of if, then, else if statements. Then we have the coalesce function, and it's kind of the same as NVL, but it allows you to have more than 2 arguments. So you can have any number of arguments after the first value you want to check, and it takes the first non-null value. But it's there is something called short circuit evaluation, which means if it finds a non-null value, it stops and it doesn't actually execute the code that you might have as the additional parameters. So you can optimize your code. If you have expensive calls, you place them last, and then you could get the cheaper value, so to speak, first. Regular expressions, they are very powerful and they are well supported in SQL and PL/SQL. Personally, I can't really remember the syntax except for a few basic use cases. So I always have to go and look up or ask somebody for help. But with regular expressions, the most important thing is to realize when you might save hours of coding by using a regular expression. So if you know what you're trying to achieve, you can always ask a guy who's an expert in regular expressions for the specific syntax. And then we have the ability to do easy date math. So you can, in PL SQL and Oracle SQL, you can just treat dates as numbers in the sense that you can subtract the date from another and get the number of days between them, or add the number to a date to get another date, and so on. And it's easy to format numbers and dates with toChar, toNumber, and toDate. And they all, compared to some other languages, these format masks actually are quite easy to, they make sense and they're quite easy to remember. Associative arrays. Now, this type of array, it tends to be used less frequently in PL SQL than in so-called mainstream programming languages, because in PL SQL, you often look up things by a key directly from a database table. But these PL SQL arrays, they can still be useful in some cases, for example, as a kind of cache to look up frequently used data. So you don't have to go to the database table to fetch the data if you repeatedly look it up in your code. And of course, Stephen has a number of presentations about how you use arrays and bulk collect and so on.
Oh yes, I love collections,
Yes.
especially associative arrays, so flexible.
Yeah. Then we have a multiset. I have to admit that I don't use this very often, but it's useful to know that it exists for those special cases where you might need this. But pipelined functions, on the other hand, I use a lot, because it's a very powerful thing to be able to construct your own data set based on any logic that you put in your function, and then be able to just select from that function to get the tabular data. So for example, you can make a remote web service call and make it look like a local table, or make your own custom search function that picks data from multiple sources, or you can check special privileges that you have in your applications and so on. So the possibilities are really limitless here. And it works great with Apex when you need truly dynamic reports. So you can just input some parameters, and as long as the number of columns you return is the same, then the content can be whatever.
So in terms of pipeline table functions, how often have you taken advantage of the pipelining part of it versus the table function part of it?
Not very often, I'd have to say. It's because the pipelining is like the being able to execute in parallel and so on.
Right, so I think they primarily come up in the context of things like parallel query.
Yeah.
And it's not to say that you shouldn't, I mean, I think the general good advice is if you're using a table function, why not go ahead and pipeline it? But I was just curious, because I think a lot of times we say pipeline table functions and then we describe a table function.
Mm-hmm.
So,
Yeah.
so yes, if you ever have a need for parallel query in which you're using a table function, make sure you pipeline it. Yep. Okay, go ahead.
Yeah. Mm-hmm. Okay. Now, in this second part, let's talk about what makes PL SQL kind of unique, and that is its tight integration with the database. So PL SQL code, it runs inside the database, which makes it easy, efficient, secure, and portable. It's easy because you don't have to think about managing connections or mapping data types or write boilerplate code to call store procedures, because you're already in the database. So the data types are the same. You have the connection. You just write your code to solve your business problem. And it's efficient because it's processing the data right next to where the data is stored. So you don't have to move the data back and forth between the server and the client. And the client might be the app server, but if you do everything in the database, it's more efficient. It's secure because it can use all the security features built into the database, and it can be used to hide the underlying tables and provide an API through which all data access must pass. So you don't have to give a direct table access. And it's portable because whether you run on Windows or Linux or Unix, the PL SQL code is still the same. So say good riddance to boilerplate code and mapping of data types and connection management, etc. that must be done in all other languages that live outside the database. So as PL SQL developers, we can focus on the business problem and not all this plumbing that has no real business value. And PL SQL is by definition highly compatible with SQL, allowing you to use the same data types and most, if not all, of the advanced SQL features that the database supports. So that means there is no need to reinvent the wheel, and you can simply use SQL within PL SQL to do advanced querying, computations, data processing. And in other languages, it's easy and tempting to use string concatenation to build SQL statements, which opens you up to SQL injection attacks. But in PL SQL, it's actually the safe and efficient way, is the easy and default way. So you would actually have to work harder to build SQL statements by string concatenation. And instead you use variables in a very natural way, and there is no need to define and bind the variables to the SQL statement. This is done automatically for you. And then we come to the type anchoring, which is one of my absolute favorites in PL SQL. It's the ability to anchor a variable declaration to a column in the database. You don't have to change code when the column definition changes, and it also documents your code in a declarative manner. So you immediately see what the variable is supposed to be used for when you see what it's anchored to. And then this is even better, the row type anchoring that allows you to anchor a variable definition to a whole table row. And you can then pass that variable as a parameter to other functions, and you can select into and update whole rows at a time. So your code is never out of sync with the table definition, which is amazing and very useful.
One quick comment about percent type and percent row type. They're not specific to SQL in the sense that you can anchor to a cursor instead of a table. You can anchor to a variable in addition to columns. So sometimes sometimes I'll create a cursor just to declare a record against it, and then I'll have that same selector. I guess I'll open that cursor in the executable section. So they're a bit more flexible. Really nice features. I agree.
Yeah, that's true. So, and I've used that as well with the when you define a cursor and when you have that type of row, which is specific to that query. Talking about cursors, with this implicit cursor syntax, this has to be the easiest way in any programming language to loop through the rows of a table. It's literally just select something and then loop. But for anything more than the most basic queries, I prefer to move the cursor definition into the declaration section. So it's easier to read, and it's also easier to copy the statement if you need to run it standalone outside your package, and so on. And then I have to say, of course, the obligatory disclaimer whenever we talk about cursors, that you should avoid processing row by row or slow by slow, and remember that SQL was designed to process data as sets. So if you can do it in a single statement, do that and do not loop. And in my experience, most tasks, they can be solved using static SQL, but PL SQL has both the execute immediate statement and the DBMS SQL package if you need to go dynamic. Just remember to use bind variables and to treat user input with great suspicion, and try to clean the input as much as you can. The Oracle database has great support for XML, and because PL SQL lives inside the database, all those features are available to you as a PL SQL developer too. And the same with JSON. The database has great support for JSON, and you can use that from PL SQL. and older versions of the database, they have the Apex JSON package, which gives you JSON support. And then we come to the PL SQL built-in packages. This is a huge topic, and there are hundreds of built-in packages to do everything from HTTP calls to zipping files to working with LDAP directories. So this is definitely a good part of PL SQL, that it has this big library that you can use. Then we have background jobs. Really more of a database feature, but usable from PL SQL, and you can put the database to work while you're sleeping yourself via the DBMS job and DBMS scheduler packages. So you can either create recurring jobs or one-time jobs. And I don't think I've ever built an application that doesn't have at least one background job to do some processing. Mm-hmm. It's very useful.
And I think it's worth pointing out that certainly DBMS job is still there, but we do encourage everybody to switch over to DBMS scheduler. In fact, I believe that job is now implemented via scheduler under the covers. And there are a few differences, but.
Yeah, I think Connor has some blog posts about what they did when you create a job. It's actually DBMS scheduler and so on, but there is still this slight confusion about what causes a commit and not. So it's
right.
I should have a slide about that, but actually there should be a way for it to use the scheduler to do transactional jobs. But I have to add that slide later.
All right, okay. We'll bring you back to do that next year with your updated slides.
Yeah. Okay, then we have the PL SQL Web Toolkit. So it's very simple CGI type of protocol where the database can emit web content from PL SQL via web gateway and back to the browser. And Apex or Application Express, it's a massive PL SQL application framework that is built on top of the humble foundations of this PL SQL Web Toolkit. And I could talk all day about how great Apex is, but let's just say that it's one of the best features of the Oracle database. There are other people who can talk more about Apex. Moving into the third part, let's look at the good parts of PL SQL when it comes to handling errors. First, some best practices, at least that I like to follow, and that is first to get in the habit of instrumenting your code by logging various debug messages, warnings, and errors. So you can either create your own logging framework, as we'll see in the next slide, or you can use, for example, the open source logger for PL SQL, the Apex debug package, depending on your environment. And you should always leave a moderate amount of instrumentation on in production. Don't turn it all off for production, because it's no good having instrumented your code if it's turned off when a problem actually happens. So it's more useful to be able to go back and look at the logs after the user complains about something than to have to turn it on and then ask him to do the same again. And then assertions, you can use that to validate input and output. We'll look at an example shortly. This is not the SQL assertion statement that is still not implemented in the database, but more of a PL SQL assertion. And then, in my opinion, functions, they should have one and only one return statement. You can technically have multiple return statements, but it makes it very hard to follow the logic. So I prefer to have a variable that holds the return value, and the last thing a function does is to return this value. So the only return statement is always at the very end of a function. So no matter how long it is, you can always see what gets returned at the very end.
You could also have a return in the exception section, right? But only one return in the executable section.
Yeah, true. And then for exceptions, you should definitely use exceptions and exception handlers instead of return codes like 0 for no error and 1 an error and so on, because then Then you have to write code to check that return code every time you call a function, and you might forget it. And so it just opens up to very low quality code. So you should use exceptions. And use the information in the error stack to track down errors. It's as part of your logging, you should always include information about the error stack, because it's very useful to know exactly which package and line number the error occurred on. And you can use the data dictionary to verify that there are no compilation errors, and also checking the compiler settings for your code. So I mentioned you can write your own kind of logging framework, but it doesn't have to be very advanced, but you should definitely use autonomous transactions for logging, so that you're sure that important information gets logged even if the main transaction is rolled back due to an error. I mentioned assertions. I always create my own assert procedure that just checks a Boolean expression and then raises an exception if that expression is not true. So we can look at an example here. So I have in this error package, so the assertion procedure is really simple. It just takes a condition and then an error message that you want to raise if that condition is not true. So if it's null or false, then it will raise an error with this message. And then, for example, let's look at how this can be used. So here we have, for example, a procedure to approve an invoice, and then I start by retrieving the invoice information, and then I use this assert procedure to say, okay, let's make sure the invoice exists, and then make sure that the status is in these valid values and so on. So if there is something wrong with the input, my code will stop here and that will raise an exception. And then I know if I get to this point, then the input should be good, and I can go on with the actual processing.
I'm really glad you pointed out the asserts. This is one of the things I really like about this is that, well, first of all, you don't need the assert package. You could say if Boolean fails, then raise application error, but you're very unlikely to write that each time. And this, so it's very simple to specify your assertions, and it becomes a declarative aspect. And it also means that you follow what I think is another general good practice, which is before you start writing your program, ask yourself, what are you assuming? What needs to be true for this thing to work right? So you do that all up at the top. And then the rest of your code becomes cleaner because you're not constantly saying, oh, wait a minute, if this is null, then do that, else do this. So I think it really creates a very nice, clean structure to your executable sections.
Yeah, exactly. And you can also say, there's another example where you have first you check the inputs, and then you do the actual calculations and the processing. Calculations, and then actually the main task that I called it here. But you can also validate your outputs, so you can assert that you actually, if you have some rules for what the result should be, you can actually check that after you've done the work as well. So it's, as you say, it becomes very clear, validate the inputs, do the work, and then validate the outputs.
And a question for you there, I see that you have these comments like perform main task. Is this actual production code or demo code?
This is demo code.
Okay.
Yeah.
So I assume your production code tends to be longer and more complex. Do you follow the same approach of writing comments to declare essentially subsections in your executable section? Do you ever create nested procedures that you call in place of a comment followed by code?
Definitely nested or sub functions that have meaningful names, so you don't have to, it's comments like these. This is more for the presentation.
Okay.
To show, but it's more or less obvious what you're doing here. So I prefer to let the code speak for itself instead of commenting too much. And use comments if there is something extraordinary going on, like if I would ask myself 2 months later, why did I do it this way? Because I know I did something a bit out of the ordinary, then I put in the comments, but not for basic stuff.
Okay.
So yeah. All right. So that was assertions, then exception handling. So as I mentioned in the beginning of the presentation, robust exception handling has been in PL SQL since the beginning, like 30 years ago. And you catch exceptions using an easy syntax, like begin, exception, end. And you should only catch expected errors and let other unexpected errors propagate up to the top level code. And what that top level code is, it depends on the situation. It might be a button click in Apex, it might be a REST call, it might be a background job, and all of these might want to handle the top or the error at the top differently. So, and then some have said that you should never use when others, then null. But in this example, I think there is you can sometimes use when others to kind of ignore the error if you're, for example, trying to just convert something and it doesn't work, then you can use this. I believe in newer versions of the database, you can actually, there are some built-in functions to do the same, but this is one usage for when others than null.
I must confess, I do have when others in my code. I will even occasionally have when others than null, and I will include a comment saying, here's why I want to continue. But do you think in general, having a when others on your procedures and functions you would avoid doing? I mean, I use it as a catch-all for log this error and then either propagate out or continue.
Yeah. So you could have a when others, then just log it and then re-raise it and then let the top level procedure handle it.
Okay.
Yeah. Okay, the error stack or backtrace, that's very useful because it lets you know exactly where, on which line the error happened, and also the other intermediate lines that were invoked all the way up to the top level anonymous block. So it's easy to see what went wrong. Some different ways to get that in different versions of the database. Errors and invalid objects, they can easily be found by doing a query against the data dictionary. And this can also be used to get detailed errors back to your code editor, such as Visual Studio Code or Sublime Text, so that you get immediate feedback about errors when you try to compile a package. So I have a blog post on my blog about using Visual Studio Code, and when you compile code, you can actually get there's the problems pane in Visual Studio that will show after you compile, and then you can then just query the data dictionary in the database to list all the lines with errors and warnings. So look into that blog post if you are interested in that. And that can also be combined with compiler warnings. You can turn on warnings for everything, and if you find that to be too much, you can selectively disable certain warnings if you find that they don't apply to you. Now a little bit about the PL SQL coding environment. You've already seen me use Visual Studio Code to edit PL SQL. So let's look a bit further into this. Some coding conventions here. Everybody has their own conventions, so just agree with your coworkers and be consistent.
Uppercase is beautiful, beautiful.
Yeah. So my recommendations or my preferences are on this slide. As I said, everybody will have different opinions, but just agree with your coworkers and you should be fine. Code generators, that's a way to quickly create error-free boilerplate code using standard formatting and comments. So I have this tool that I made myself that I call Quick PL SQL. There is quick SQL in Apex, and this is quick PL SQL that allows you to type some simple markup here and then generates all the code for you. I have a blog post about that as well, and there is a link here. So it's an Apex application that just calls a PL SQL package to generate your code, and then you can download the code as a script or as a zip file with all the separate package specification and body files. And there are also this OddGen or ODDGen that is a plugin to SQL Developer that you can use to make your own templates for code. Also, don't forget that you can use the data dictionary to quickly generate code. If you need to do something, then you can, for example, do a simple select to get a bunch of drop table statements. So you don't have to type more than you need. And I've mentioned Visual Studio Code a couple of times. I have a blog post about it. You can use that on all operating systems, Windows and Macs and Linux. And you have some nice PL SQL extensions there. So I can go to the extensions here, and there's this language, PL SQL language plugin by XYZ. So that does all the syntax highlighting and code completion stuff. It means that you can also right click to say peak definition, and you can actually look into the definition of other code while you're still inside the main code. And I use that all the time to quickly look into what the other procedure is doing. So look into the blog post if you're interested in that. I use SQL Developer more for browsing the database objects and running queries, and then I do the PL SQL coding in Visual Studio Code. And in PL SQL Developer, you can also do PL SQL debugging. To be honest, I prefer to use logging and instrumentation to debug and find errors, but it's good to know that there is an interactive PL SQL debugger if you need it. So yeah, SQL Plus, it's a old but nice tool that you will be very productive with, be able to run scripts for deployment and patch your applications. And of course, the new SQL CL is even better. Quoted literals, that's nice you don't have to resort to double quote characters. And then, like I said, the data dictionary can be used to, for example, this is a small snippet that I use all the time to just find reference to some functions that I made. I want to see where it's being used. I can quickly search through the source code and find it. And this is to find, okay, how many lines do I have? How big is this application? So queries, small queries, easy queries, but very useful. And you have dependency tracking inside the database, which you can easily view from the data dictionary as well. PL scope, that's even more advanced way to find information about your code. You can use that to find code that doesn't conform to your coding conventions. So you can say, okay, I want to find all the variables that don't start with L for local variable. And this query will tell you. Conditional compilation, it's useful to know that you can use it, and there is a presentation here by Scott Wesley that shows how many things you can use it for. And for production deployment, there is no reason to not set the PL SQL optimizer level to level 3 before you deploy to production.
Just to go back there for just a second. So the default optimization level is 2, and the optimization level 3 means that it'll do everything that 2 does plus subprogram inlining. So if you have functions and procedures that are called inline, so local nested modules or private subprograms and packages, I believe as well. Basically, when you compile the code, it'll move all the body of your procedure and function into inline in your program. So your compiled code gets bigger, but there'll be less of a runtime cost.
Mm. Yeah. And I guess for most people, that's an acceptable trade-off.
Yeah, right. Sure, make my compile time unnoticeably slower so it'll run faster at production runtime.
Yeah. Yeah, and then you can use this query to just check what the actual settings are for the code that's already in the database. Again, I really like that all this information is available in the database. You can query it and you can use SQL on top of it. So it's all this meta information is readily available. Yeah, and as I mentioned, there is a lot of functionality in the database you can use from PL SQL. There's a lot of built-in packages. Apex has a lot of useful packages. I have an open source library called Alexandria utility library that you can use. You'll find it on GitHub. And there's also the Aura open source project that has some open source offerings. Now for the final part here, we'll talk about some bad parts, because like everything else, PL SQL is not perfect. So here are some of the things that annoy me. So it used to be a limitation that you could only have 30 characters in names of tables and packages and variables. And it was always very annoying when you have a great name, but it's 31 characters. But in Oracle 12.2, I think it was, this actually was increased to 128 characters. So that is no longer a limitation.
Hooray!
Yeah. And then we have this that I mentioned at the beginning of the presentation, that you can't use PL SQL package constants in SQL when you call it outside of PL SQL. So if you have a view, for example, you can't use these constants, and then you must put back the hard coding of these values. And it means that if you have used constants in PL SQL and you just want to copy and paste the query into SQL Developer to run it there, you have to go back and change from the constants and back to the values. So it's very annoying, and I don't understand why, when the database supports functions in SQL queries, it should be easier to support constants in queries. So
I can't speak to the why on this one. I am hopeful that it will change in the future, just like you are. But you can now do a with function call in your SQL statement. So it seems like a good workaround for this right now. If you're referencing the same constant multiple or the same value multiple times in the same select, you could create a function inside your select that calls the constant, and then you call that function, right? So you avoid the hard coding, but you introduce more context switching.
Yeah, and more coding.
Just thought I'd point that out. Yeah. If it's really, really bothering you, we do offer you a way to avoid hard coding in SQL.
Yeah.
It's just not the best solution.
The best solution is probably the simple solution, and that is to get support of constants. So.
Yep.
All right. Those were limitations, some annoyances. So there is no Boolean data type in SQL, so it's not possible to call PL SQL functions that use Boolean parameters from SQL. So you just have to use like a yes/no parameter string instead. And in triggers, there is this concept of old and new records, but you can only use those within the triggers. You can't pass them to a procedure or a package. It would be very nice if you could pass this old and new record into your own procedure, do something with it and return it, so you don't have to put all the code in the trigger, and you could have the code in the package instead.
Yes, that would be nice.
Yeah. And then UTL file, it has functions to read a file and to write a file and so on, but for some reason you can't get a list of which files are in a folder. So I guess it's less of a problem now, that it tends to be more integration with the web services and so on. But if you receive files, it's very useful to know what files have I received in a folder to be able to process them, but PL SQL can't tell you. So there are some workarounds with you can use like pre-processing of external files and so on. But there should just be a function in that package to get the list of files. Okay, so that brings me to the very end here. It's basically some links to the PL SQL language references and your YouTube channel, Stephen, and to Ask Tom, where you can ask questions from the experts. And I'll end with the old advice from Tom Kite that you should do it in SQL, and if you can't do it in SQL, do it in PL SQL. And if you can't do it in PL SQL, only then do it in Java or whatever other language. So even though PL SQL is great, if you can do it in SQL, that should be your first.
Even greater.
Yeah. So that was the end of my presentation.
All right, thanks. Let's go to questions. If you could stop sharing for a moment.
Yeah.
Since we'll do some chatting for a few minutes instead of looking at slides. Great. So some questions. So we had a couple of questions around the tools you use, but you covered that. Excellent. There are a number of requests for the code. Is all the code that you're showing in the presentation today, is that already online on your GitHub repo or somewhere else? The various packages?
I just put it together for the presentation, but I might put it into a GitHub repo just to have it available as a demo.
So we'll steer people to the repo. Excellent. I'll put a link. I'll add a link to the session on Ask Tom, so it'll be there forever. Can you please shed some light on the real-world examples where pipeline table functions are used and its advantages? Go, Morten.
Yeah. So as we talked about, that would be then actually table functions, and not necessarily pipelined functions. So one real-world example is that, say you have in your application, you have a search field and you want to show the user's hits from different tables. Mm-hmm. So inside your table function, you could do a select from 2 or 3 different tables, and you could output it as search results in the same result set. So in, for example, Apex, you could have a report that uses the search results template, and it could just list all the results, and then you would have different links pointing to different pages based on what type of table you have the data from.
So in a sense, the table function in that instance acts as a kind of parameterized view, which is pretty cool. And in general, I'd say for table functions, it allows you to programmatically construct a data set. Your table function doesn't even have to have SQL inside of it. You can literally add elements into a collection, return the collection, have it treated as a table. So lots of different possible use cases there. There was also a question around context switching. So you'll certainly have a context switch to call the function from SQL, but the function is only called once. So I think context switches is not an issue for table functions. If you're calling a function in the where clause or in the select list, then you need to be very aware of the number of times it'll be called and the overhead of the context switch. In terms of pipeline table functions, number one, parallel query. So if you're doing a parallel query and you're calling a table function, you got to pipeline it, and there's really no downside to it. The other use case I've heard about, though I have never implemented myself, is that if you have a web page that's taking a long time to display because somebody typed in some criteria and you're returning 100,000 rows of data, well, people don't want to sit there and wait as the little scroll bar on the side gets smaller and smaller and smaller. So my understanding is that, for example, in Java, you could be calling a pipeline table function and consuming the rows being returned. And you could display, for example, the first 100 rows returned while the function is still actually getting more data. So that's another general criteria to look for concerning table functions, pipeline table functions. And there was a comment in general when Morten, you were talking about the tight integration of SQL and PL SQL, that there's a performance impact every time your PL SQL code executes some SQL. So between SQL and PL SQL, you're always going to have a context switch. And another question that came up with it, or sorry, the same question from Dear DBA, what are the ideas you have for reducing the number of context switches? Any thoughts there?
Yeah, I'm looking at the question, but I'm not sure I see the actual, it says the PL SQL code must execute some dynamically generated SQL, then back to PL SQL, then back to some other dynamically. But
I don't know if dynamically generated matters too much in general.
No, because the idea is that your data is in the database, your PL SQL is close to the data. So when your client says, okay, go and generate these 500 invoices for me, you do it all in the database, and then you return the results. There is no dynamic SQL involved. There is no context switching. You just go and, well, there is context switching when you execute your queries inside PL SQL, but still it will be faster than doing it from outside the database. And I think Toon Koppelars has shown in his videos that you can have like a 10 times or 100 times speed up if you do it inside the database. So this is not just theory, it's provable in practice.
So definitely moving database-based logic, data logic into the database, pretty clearly you'll get an advantage. You'll reduce the switching between the middle tier and the back end. In terms of context switches within the SQL PL SQL realm, number one, bulk processing. So using for all or bulk collect drastically reduce the number of context switches. And then I think mainly it's on you to look at your SQL. So calling our own functions in a SQL statement, really great stuff. But you got to be careful about how you do it. So the number one issue to look for is calling that function in the where clause, right? Because then it's being called for every evaluation. In the select list, even then it's not so bad unless you're returning a ton of rows.
Mm-hmm.
And the other big thing I would say to watch out for is if you're calling a function from within SQL, there should not be SQL inside the function. Right, so SQL calls PL SQL calls SQL calls PL SQL. That's a real killer, and there are a number of issues related to it, but certainly context switches. So keep things simple. Avoid SQL within your functions that you call from within your SQL statements, and I think you'll be in pretty good shape then. We have a comment from Nils. To use variables from packages in SQL, like for views, you can declare an object type and a corresponding variable in a package, and a single function to return that instance. And in the SQL, just use a with data as select package function from Dual. So Nils, I think I like that. I like the idea. As Morten was pointing out, yeah, we write a lot of code to work around some of these things, but you do what you have to do. That's the byword of programmers.
Remember that we like PL SQL because it's easy and simple. So we don't want these workarounds that require you to write like Java levels of code to do something.
Yeah, and by and large we don't, but we still have some gaps, as you pointed out in your bad part section. Sasha asks, what about new features in 19C? What about that, Morten? New PL SQL's features in 19C.
Yeah, that's more your
oh, okay. Well, the answer is there aren't really any new features in PL SQL in 19C. There were some in 18C. In fact, I just did I've done a number of talks recently in various locations on newer features in PL SQL. The major addition in 18C were qualified expressions. Essentially, you can call a constructor function for an associative array. And that's very cool. And in 20C, which has been available as a preview basis for a while now, there are a number of really interesting new features, especially around iterators. And by the way, you'll be seeing announcements very soon, before the end of the year, about 20C and more importantly, 21C. So keep an eye out for that. And there will be a blog post coming out on the Oracle PL SQL blog that identifies a number of the new features that you'll be seeing in, I'll say it right now, in 21C. So there's good stuff coming up and major simple. So in terms of more, and you're concerned about keeping things simple, the enhancements around iterators, loops, are incredible. And some of it is like so complicated you'll probably never use it. I'm sure I never will. But some of it is so sweet, goes right to the sweet spot of some of the things we do now to write too much code when we shouldn't need to. So do check all of that out. And here's a question from Jamal. I have an old view where the query uses a function in the where clause. Now the table is too large, so I move the function into a select in my view and joined it to the main table. Now the function runs only once. Good move. And the performance is much better, but I cannot run DML operations anymore due to The 1779 cannot modify a column which maps to a non-key preserved table. Why would that affect DMLs? I'm just selecting context value, and it's not a column in the view, but only used in the where clause. Do you have a thought about that, Morten? I don't have a thought right off the top of my head.
No, I guess it's the join that causes the problem. That the Oracle is not able to find out how it should update the rows anymore. So, but you could look into instead of triggers, I guess.
I was going to say, right. Create an instead of trigger to bypass it. Yeah. I mean, in general, if you're doing DML against views, they need to be simple views. So what you might want to do is have an alternative view if you don't want to change that at all. Also have an alternative view that you use for your DML operations. Okay, we have a lot of things here. And Nils suggests that for table functions, they're especially useful for doing pivoting, at least before pivot and unpivot were available in SQL. And Petrus asks, do SQL macros not resolve context switching? Morten, have you heard about SQL macros?
I've heard about it. Haven't really tried it out myself.
Haven't done too much with them, but so SQL macros were introduced in 19C, actually. They were officially announced in 20C preview. Some of it was backported. Table macros were backported into 19C. The general idea behind SQL macros is that you can define a PL/SQL function that returns a string, but what you're actually, and you can pass in parameter values. And what it does is construct a string that is actually inserted into the SQL statement itself. So you're doing text substitution. So in that sense, absolutely, there's no context switch. And if you can avoid, so in that sense, Petrus, yes, SQL macros resolves context switching, but only for, I think, a very narrow number of cases where you probably should have been avoiding a context switch already, in the sense that, sure, you could take all the code in your function that you currently call enforce a context switch. You could put it into a SQL macro function and return that code as text, as code. So if the body of the PL/SQL function was SQL code, you could put it into the SQL statement via macro. I'd say those are very few occurrences. So the answer I'd say generally is that SQL macros and context switches are different things. You're not addressing one with the other. And I think as you get into the feature more, you'll see what I mean even more. Okay. How do you version control your Apex applications? Morten?
Well, first of all, I put most of the code inside of PL/SQL packages. And in Apex, I only have one-liners that call packages. So there is as little code as possible. And you can even use the data dictionary to find, or the Apex dictionary to find where people have put more than one line of code or more than one statement.
That's right, you just posted that.
Yeah. And by the way, in Apex 19, I think, there has been some enhancements where you can export the whole application as a zip file, and it will have the different parts of the application are separate files without all the IDs and stuff that tended to make version control of the files problematic before. So you can look into that in Apex 19. I'm not sure if it's 19.1 or 19.2, but yeah.
Okay, let's see. I've got a long one here about, I was using pipeline table functions to generate interactive reports in Apex 20, and then use table functions with the type, but I always had a lot of contention with explicit curses of my packages, even though I used bulk into functions to optimize it. Now I ask you, when being presented in front of a high volume of data, what is the recommended method for the data source in an interactive report? So I guess the question is whether you would use SQL versus a table function in an interactive report if you're talking about lots of data.
Well, I guess one of the questions you have to ask is, why does the user need all the data? It's like, typically it doesn't make any sense to make a report that has thousands of rows, because nobody's going to look through everything anyway. So why are you returning all this data?
And so you're saying filtering options to let them filter in advance what they're looking for.
Yeah.
But it sounds like also in general, this is not an area of expertise for me, that if you are returning a lot of data, probably using SQL and not a pipeline function. Well, first of all, as far as I know, Apex can't take advantage of the pipelining feature in which you're sending data back before the function is completed. I don't think it will pick up the data and use it. So I don't think there's a benefit to pipelining. And in general, table functions versus straight SQL, with straight SQL, the built-in engine in Apex, I think, and it's getting a lot smarter about it, will be able to work with your data directly in a sense and manage it directly in the report. Whereas in the pipeline table function, it's building that data set and then passing it all back. So my sense would be probably for very large data sets, number one, see what you really need to do and if you can trim down the amount of rows. But otherwise, I would stick to SQL as much as possible. So I've got a few more questions. We are over time, but I guess I'll just work through the rest of the questions if it's okay with you, Morten. And if you can't stay on, folks, just drop away. Is it possible to execute PL SQL procedures and functions in parallel?
Well, one way to do it is to create a job, a one-time job. Then it runs using a job process in the background. So if you have lots of processing you need to do, but you can take separate parts of your data and work on them. You can just spawn a number of jobs.
Mm-hmm. So I think actually, let me rephrase your answer. The answer is no. We don't. So PL SQL is not a parallelized language. You can't say run these 15 functions in parallel and then we'll deal with the results back. You have to do it yourself, and the way you can do it is use DBMS scheduler or job to spawn jobs running in the background. But then you have to create the architecture that says, are they all done? Gather the data back, do something with them. So in general, if you need to do a heavy parallelization of code execution, PL SQL is not the place to go, and I don't think we're going to be adding that certainly anytime soon. But there are opportunities to parallelize, like parallel pipeline table functions, and also there's a DBMS execute parallel or parallel execute that allows you to specify parallel execution of DML statements. Can we
also,
pass? Oh, go ahead.
You have like a long-running thing that you need to do when a user clicks the button, for example. Why not just create a background job that does the work and then just tells the user like, okay, you can refresh later to see if we're done, but now it's the job has started, so he doesn't have.
I just did that. In fact, in Apex, we had a report where they wanted to see the country of the user, and I have to do an LDAP lookup to get the country. Oh, that's slow. So now I just say they click the button, send me a country report, and I spawn a job. It churns away in the background, and it sends an email with the report attached. That was nice and very easy. Yeah. Can we pass record types in a dynamic PL SQL block, function, or procedure?
Yes, we can.
Yeah, so as of 12.2, this is, and you can even pass Booleans. So now in execute immediate statements, and even DBMS SQL, you can actually use PL SQL specific types. So only dynamic SQL. But I think even in static SQL right now, you can pass Boolean parameters into a PL SQL function that's called in SQL. And here you're such a troublemaker, Morten. From Rachel, is there any plan to add a function to util file to return the list of files in a directory in the future? Now, in general, Rachel, we don't answer things about the future, but I'll give you something of an answer here. Do not wait for a new function in util file of any sort whatsoever. Obviously, the trajectory of computing in general is onto the cloud. And once you move to the cloud, the idea of manipulating files in the operating system really pretty much disappears unless you've got your VM and you're just running your own bare metal machine. So for example, in the Oracle Cloud, what you'd be doing is accessing object storage and files and elements in object storage. And it wouldn't happen through util file at all. So I would be very surprised if we have any enhancements in util file ever again. I'm sorry, Rachel. Rachel doesn't have a cloud. Soon, we'll all have clouds. Well, actually, you can have a cloud, Rachel. So we have a free trial, 30 days or $300 in credits. And after that, you just have an always free or autonomous database and cloud services. So you can get a free Oracle Cloud service. I realize that obviously many people will not be on the cloud for a long time, if ever, and you would like enhancements to util file. I'm just trying to set expectations appropriately.
So what you could do as a workaround is to create your own or have like a local server running that is able to take commands and return data. So then you would, instead of UTL file, get a list of files, and you can call a web service that will return a list of files. So then you would have to implement that web service in a different language that is able to read the directory, but shouldn't be too much work.
Well, and as Nils pointed out, and I just put in a comment, so one of the workarounds that has been clearly identified is that you can use an external table. So create an external table, which is basically treating a file as a relational table. And then you can use the preprocessor option to basically run an operating system command and pull out the list of files or do anything else. So do a little bit of searching on your search engine. I would just search for external table, preprocessor, file, something like that. And you'll find, I believe actually Tom Kite wrote about it before he retired. So it's been several years ago now, but you'll see a number of ways to do that. So that's something you can do right away. Then it's simply a matter of having the OS privileges to read the files from within the database. Thanks, Nils, for that. Okay, so we're way past time. Morten, thanks for staying on. Thanks for the great presentation. I think everybody enjoyed it very much. And so we'll post the presentation, the video, and you'll update your GitHub repo with the code base. And we'll provide links to all of that on the Ask Tom Office Hours page. So thank you again, Morten. Thanks for everybody for joining us. Have a safe and healthy rest of 2020. 2021, it's got to get better. I'm sure it's going to get better, even though in the United States, it's going to take a while. So happy holidays, everybody. Happy coding.
Bye-bye.
Take care.